Hello everyone. In today's concept boost exercise for JEE Advanced video, I have chosen a very special topic for you, that is algebra. And to begin with, I have started with the first question from the complex number. It is still being written on the screen. You can read it out. The question says that if A, B, C and omega are complex numbers such that A plus B omega plus C omega square equal to P, B plus C omega plus A omega square equal to Q, and C plus A omega plus B omega square equal to R, where omega is equal to e to the power iota 2 pi by 3. Then the objective of this question is that we have to find the value of mod of P square plus Q square plus R square whole divided by PQ plus QR plus RP. And mod of this complex number says A, B, C and omega are complex numbers, so P, Q, R are also the complex numbers. So before proceeding, I will encourage all of you to pause this video here, and you should first solve this question on your own and see whether you are able to solve this question within 3 minutes or not. Before that, let us see the level of difficulty of this question. According to me, this question, the level of difficulty of this question is of medium level. This is not neither too difficult to solve nor too easy to solve. So if your preparation have been up to the mark, then you should be able to get the correct answer within 3 minutes. In case you want to see the answer, here is the solution. So you can observe from the given three expressions that if you add the three expression term by term, right, I mean P plus Q plus R, then you are getting A plus B plus C plus omega, taking omega common, A plus B plus C, taking omega square common, then A plus B plus C, and taking A plus B plus C common, we are getting 1 plus omega square, which is equal to 0. We all of us know. So the question is sorted now, squaring both sides, and we are getting P square plus Q square plus R square plus 2 times PQ plus QR plus RP, that is equal to 0. So from here we are getting, I can take that bracket on the right hand side and then taking modulus both sides. So we are getting basically mod of P square plus Q square plus R square equal to mod of minus twice PQ plus twice QR plus twice RP, then closing the mod, and then dividing both sides by taking minus 2 common, dividing both sides by mod of PQ plus QR plus RP, we are getting the correct answer, that is equal to 2. So this question was of moderate level difficulty, and obviously a very good question. If you could have solved this question on your own, this would have boosted your confidence, definitely. Let's move on to the second question, and the second question is this is being written on your screen, so just wait a minute. Second question says that if a equal to it should be 1 plus x cube divided by factorial 3 plus x to the power 6 divided by factorial 6 plus x to the power 9 divided by factorial 9, and so on up to infinitely many terms. Similarly, another number b is equal to x plus x to the power 4 by factorial 4 plus x to the power 7 by factorial 7, and so on, x to the power 10 by factorial 10, and so on. And last number c is equal to x square by factorial 2 plus x to the power 5 by factorial 5 plus x to the power 8 by factorial 8, and so on. These three expressions are somehow related to the expansion of e to the power x. You must have studied those expansions in the limit chapter of the calculus. Then what is this? You have to find the value of aq plus bq plus cq minus 3abc, right? Looking at these expressions, first of all, finding the value, which means that any real number as an answer, it looks very difficult, because AQ plus PQ plus CQ. If you if you start this question, solving this question from the very basic, then finding the AQ, BQ, and CQ is very difficult. In fact, the level of difficulty of this question is really very difficult. Uh, let us see, there must be some other way. We know that if we factorize AQ plus BQ plus CQ minus 3ABC using complex cube root of unity omega, we know that this is equal to a plus b plus c into a plus b omega plus c omega square into a plus b omega square plus c omega. Now, we should check each factor one by one. Let us see, let us check each factor one by one. So let us check first factor a plus b plus c. If we add all these expression a, b and c and then arrange the uh, terms in increasing power of x, what we are getting is this is equal to e to the power x. Similarly, looking at the second expression, a second factor, you can see that multiplying b by omega and then multiplying c by omega square and then adding term by term, what we are getting is a plus b omega plus c omega square is equal to 1 plus omega x plus omega square x square by factorial 2. Similarly, next term is omega cube x cube divided by factorial 3 and so on. This is nothing but it is equal to e to the power uh, omega x. Yes, if we expand e to the power omega x, or if we replace e to the power x by omega x, you should get that expression. And the last one is slightly tricky. Why it is slightly tricky? Because we have to do some arrangement to accommodate this special term so that you can express this new expression for some power of e. So let us see. I think there is a mistake. Yes, there is a typing mistake. It should be, the first term should be 1. Okay, so a plus b omega square plus c omega, this should be equal to 1 plus omega square x plus the third term should have been omega into x square. Instead, I have written omega to the power 4 into x square. Similarly, next term should have been x cube by factorial 3. I have written omega to the power 6. It has been purposely done. The reason is we can replace omega by omega to the power 4 and we all know that omega to the power 6 is equal to 1. Why I have done this? Because now this expression fits to the expansion of e to the power omega square x. So if now I multiply all factors together to get the expression aq plus bq plus cq minus 3abc, what we are getting, this is equal to e to the power x into e to the power omega x into e to the power omega square x. Yes, be careful, there is a typing mistake. This should be e to the power 0, which should be equal to 1. So there is a typing mistake, please correct it. I have already recorded this video, so I cannot correct this typing error. I'm just giving the voice it right now. So the correct answer should be uh, e to the power 0, that should be equal to 1. But there is one potential question that is coming out of this concept. I mean, one more question can be framed. Instead of asking the value of aq plus bq plus cq minus 3abc, you could have been asked to integrate this expression, uh, not necessarily from 0 to infinity, because I have made a mistake here in writing e to the power the final answer. I thought that it is my e to the power minus x, and that's why I said that to integrate from 0 to infinity. But in case suppose a to b, and then this could have been even more difficult question, because first of all, seeing these expressions abc, it looks daunting. Like suppose somehow it was e to the power minus x, and then you could have integrated it from 0 to minus infinity, 0 to infinity, and the answer would have been very easy. You can see that it would have been 1 by a. So this is really a very good question to learn some deeper concepts and the potential question that can be framed from the already solved question. This happens quite often, that some question which you have already solved, and with slight change or modification in the concept or in the language or in the data of the already solved questions, a new question can be created. So this is one such example of how to create a new question out of the already solved questions. Now moving to question number 3. See, next question, that is question number 3. I have chosen this question from the topic permutation and combination, and this is excellent question. Excellent question. I'm again telling you. Uh, okay. So before that, let's see one question from the complex number, and this question again involves some unconventional concept. Say, you have to find the number of non-zero complex numbers that is satisfying the simultaneous equations z to the power 100 is equal to 3 z bar and mod z equal to 3. Obviously, z bar you already know, it is conjugate of z. So how to solve? Before that, let us see what should be the difficulty level of this question. According to me, this question should be of moderately difficult. It's a medium difficulty level. So how to proceed, how to start solving this question, and how what can be done to directly, because you are not asked to find the value of z, rather you have been asked to find how many complex numbers. So let us see if multiplying first equation both side by z, and we are getting the expression z to the power 101 is equal to 3 to the power 51. So z is equal to 3 to the power 51 and whole to the power 1 by 101. This is nothing but z is 101th roots of unit of not unity, it is 3 to the 51. So this should have total of 101 number of complex numbers. One of them is 0, so total number of non-zero complex number is equal to 100, because barring 0 out of 101, you are getting 100 complex numbers that is satisfying both simultaneous equations. So this is again one of the very interesting and based on the simple concept, but yes, how to apply those concepts, these questions are illustrating in a very better way. Yes, the question which I was talking about, the question from the permutation combination, the question is find the number of six digit numbers. Find the number of six digit numbers using the digits 1, you can see 1 comma 2 comma 3, then 4 5 6 7 8 9, such that these six digit numbers so created are divisible by 3, and we all know that for a number to be divisible by 3, and yes, there's some of their digits must be divisible by 3. In fact, the level of this question is difficult. Indeed, the question is difficult for the reason that is very obvious from the solution. Let us see the solution. Solution is, let us say we have six place to be filled out of that 9 digits, and so since the question did not say that, we do not have to use the repeated, we do not have to use repetition. The question has not said this, so we can use the repetition. So the first place can be filled with 9 ways, second 9 ways, third 9 ways, and similarly fourth and fifth also in 9 ways. Let's say that in the first place, let us say the first place on the left hand side, on the extreme left side, I'm filling the first place with the digit x1. Let's say there is one digit x1, and I'm going to fill that place with x1, second with x2, third with x3, next with x4, and this next with x5. And I have left that last place. Let's first check the sum of digits x1, x2, x3, x4, and x5. So there are three possibilities. Either sum of these five digits are multiple of 3. In that case, the sixth digit must also be the multiple of 3, so that the overall sum of the six digits would be multiple of 3. Then the sixth digit, I mean the possible value of x6, let's say the sixth digit is x6, it can be either 3 or 6 or 9. Similarly, suppose that sum of the first five digits is equal to 3k plus 1, right? In that case, the sixth digit must be either I guess either it should be 2 or 4 or 6, so that sum of all six digits is divisible by 3, in order that number should be divisible by 3. And again, one more case is possible, that if sum of the first five digits, that is x1 plus x2 plus x3 plus x4 plus x5, is equal to 3k plus 2, then the possible values of the last digit, that is sixth digit, can be either 1 or 3 or 5. So we can see that in each case whether the sum of first five digit is equal to 3k, or it is equal to 3k plus 1, or it is equal to 3k plus 2, in each case we can choose sixth digit in three possible ways. And therefore, using the multiplication principle, of counting, we can say that total number of uh, such numbers, such a 6 digit numbers x1, x2, x3, x4, x5, x6 bar, such that these are divisible by 3 is equal to 9 into 9 into 9 into 9 into 9 into the last place can be filled by 3 ways, so 9 to the power 5 into 3. So yes, the answer is being written on the screen. Total number of ways is equal to 9 into 9 into 9 into 9 into 9 into 3. So you should be sufficiently prepared enough to appreciate the solution of this question, because uh, after solving this question, since now I'm giving only the voice and I'm just explaining the method, I've already uh, solved this question, so you should be able to appreciate the concept. And you can see here next question, that is still yes, this question is again from complex number, and this is a wow question, for the reason that is going to be obvious after you see the solution. Let us first see the question. If z1 and z2 are the two non-zero complex numbers, such that you can see here 3 times mod z1 equal to 4 times mod z2, and these z1 and z2 are non-zero complex numbers, none of them are equal to 0. Now suppose that there is a complex number z which is equal to 3z1 divided by 2z2 plus 2z2 divided by 3z1, right? So this is a new complex number in terms of z1 and z2. Then we have to find, in fact, there are four subparts of this question. There are four parts of this question. The first part says we have to find the maximum value of mod z. Similarly, second part says that we have to find the minimum value of, I think it should be the real part of z. Yes, this question is really very interesting, and indeed this question has some deeper concept. Third part says that we have to find the maximum value of, we have to find the maximum value of imaginary part of z. And the last part says that we have to find the locus of z in complex plane. So there are four parts of this question, which is clear on your screen, clearly written on your screen. And you can see that there is just one relation in terms of modulus. Nothing has been said about the argument of z1 and z2. But we know that using Euler form, we can express any complex number z as z equal to mod z into e to the power iota times argument of z. We all know that is, we can write z equal to r e to the power iota theta. But what is r? R is mod z, and what is theta? It is argument of z. Level, yes, this is it. This question is tricky. Uh, so let us see. Suppose that 3z1 divided by 2z2, right? And we do not know the argument of the complex number 3z1 divided by 2z2. In fact, we do not know the argument of z1 or z2. So if I use the given relation that 3 mod z1 equal to 4 mod z2, we dividing both sides by 3 mod z1, then we can generate that mod of 2z2 divided by 3z1 equal to 1 by 2. We can clearly see it. You can be, by a simple rearrangement, you can see we are getting this. Let us suppose that the argument of this new complex number 2z2 divided by 3z1 is equal to theta. Then using Euler form of complex number 2z2 divided by 3z1, we can write 2z2 divided by 3z1. Let's say this is a new complex number that is equal to mod of 2z2 divided by 3z1 into e to the power iota times argument of 2z2 divided by 3z1. And as we know that the first modulus is 1 by 2 and the argument is theta, which we have assumed. So 1 by 2 into e to the power iota theta. Then look at z. Z is the first term, and next is the reciprocal of first term, right? So in fact, I have first found the second term, and I'm going to write the first term as a reciprocal of second term. So reciprocal of 1 by 2 into e to the power iota theta is nothing but 2 into e to the power minus iota theta. So z should be equal to 2 into e to the power minus iota theta plus 1 by 2 into e to the power iota theta, which is equal to 2 into, converting them into polar form, cos theta minus iota sin theta, plus 1 by 2 into cos theta plus iota sin theta. And let's say that the complex number z is equal to x plus iota y. So let us suppose that z is equal to x plus iota y, and then replacing z by x plus iota y, we are getting x plus iota y is equal to 2 cos theta plus 1 by 2 cos theta. I mean, putting the real part together and then taking iota common and putting the imaginary part together. Then from here we are getting what? Minus 2 sin theta plus 1 by 2 sin theta. Right. So if we rearrange the terms and equating the real and imaginary part from both sides, we are getting that x is equal to nothing but it is 5 by 2 cos theta, and y is equal to minus 3 by 2 sin theta, where theta is a parameter because the argument is not given. We have assumed theta, it can be anything. It can be any possible value of the argument, right? So first of all, if we eliminate theta to get the locus of x and y, in fact the locus of z, we are getting x square by 5 by 2 whole square plus y square divided by minus 3 by 2. Oh, there is a typing mistake. It should be minus 3 by 2 whole square. So this is basically equal to 1. By now I should be able to recognize this equation. This is a famous standard equation of ellipse. So the locus of z in the complex plane is ellipse. So you have solved the last part of this question. Let's move on the first part. Or let's move on the second part. X is equal to real part of z, which is 5 by 2 cos theta. Now I should be able to solve each part because now you know x and y in terms of a variable theta, and maximizing and minimizing the cos theta and sin theta is a very easy task for those who are preparing sincerely for JEE Advanced. So maximum value of real part of z is 5 by 2. Similarly, minimum value of the imaginary part of z is minus 3 by 2, when sin theta is equal to 1. And the first part is we have to find the mod of z. So using the relation mod of z is equal to under root x square plus y square, we are getting mod of z is equal to 5 by 2 cos theta whole square, and then plus 3 by 2 sin theta whole square. In fact, it should be minus 3 by 2 sin theta whole square, but it is immaterial. So we are getting is 25, yes, 1 by 4. Taking 1 by 4 common out of square root, we are getting 1 by 2 in the coefficient, and then we are getting this. So in fact it is equal to 1 by 2, 9 plus 16 cos square theta. It is a very simple rearrangement of terms, and just cos square plus sin square is equal to 1. So therefore, what should be the maximum value of mod z? When cos square theta will be maximum, the maximum value of mod z will be equal to 1 by 2 into square root of 9 plus 16, which is equal to 5 by 2. And the minimum value of mod z is equal to 1 by 2 into, when cos square theta is equal to 0, in fact it should be 3 by 2. And this maximum value of mod z and minimum value of mod z, it can also be obtained directly from the graph of ellipse. If you draw the graph of ellipse in complex plane, you can see real axis and imaginary axis. And then if I draw the ellipse, so let us say, suppose that this is the ellipse, this is that ellipse which equation is given, and let us suppose there is a point z on the ellipse, right? So let's say it is in first quadrant. Let's say this point is z, and this corresponding point, I mean the fx is z and the point is p. In that case, maximum value of z will be obtained when this point p coincides with a, and the minimum value will be obtained when the point p coincides with the point b. In that case, maximum value of mod z will be equal to oa, and minimum value of mod z will be equal to ob, right? And that is equal to respectively 5 by 2 and 3 by 2, which we obtained algebraically also. Here from the graph itself, we are able to appreciate, we are able to directly recognize the maximum and minimum value of mod z, and from calculation also we got the same answer. So this is in fact a very deeper concept, right? Because some students get confused what to do with the argument, because the argument was not given in the beginning. Now the last question of the video, and this question is really amazing question from binomial theorem. Let us see, we have to find the value of this series. There is a binomial series, and this is slightly tricky part, because binomial in general, I have seen that the students generally tend to ignore the series which involves the binomial coefficients. But by the end of this video, you will be amazed to see that how we can apply, how trick, I mean in a tricky way we can apply and solve these concepts, these questions in a very simpler way. You can see that if we expand x plus y whole to the power 100, Then coefficient yeah, or in you can say that 1 plus x whole to the power 100. Then coefficient 100c1 is nothing but it is the coefficient of x to the power 99, and 100c2 is the coefficient of x to the power 98. But in 2c1 you can see 2c1, I mean if we expand 1 minus x or 1 plus x whole square, so 2c1 is the coefficient of x to the power 1. So coefficient of x to the power 98 is 100c2, and x to the power 1 is 2c1. So again x to the power 99 overall. Let's say that s is the value of the given series, right? So then s should be equal to coefficient of x to the power 99 in the series, in fact, that I'm going to write just now. So this s is equal to coefficient of x to the power 99, which I have missed writing that sentence here, but I'm explaining you that s is equal to coefficient of x to the power 99 in 100c1 into x to the power 99 into 1 minus x to the power 1. Similarly, plus 100c2 into x to the power 98 into 1 minus x to the power 2, because if you expand 1 minus x whole square, you will get 2c1 again, and then x to the power 99 taking common. Similarly, 100c3 x to the power 97, 1 minus x to the power 3, and so on. Last term should be 100c100, 1 minus x to the power 100. So in this series, the coefficient of x to the power 99 is equal to s, which is our sum actually. So yes, in the next line I have uh, also written the full sentence, that coefficient of x to the power 99. Yes, so in the next step, it is equal to coefficient of x to the power 99 in the expression. Now if we add 100c0 into x to the power 100 in the above expression, that is not going to change the coefficient of x to the power 99, because adding the coefficient or any term that is different from the x to the power 99, the coefficient of x to the power 99 is not getting affected. So that's why I have added 100c0 into x to the power 100, so that we can express this entire series in terms of a very standard and very convenient known series. And you can see that in terms of y, you can assume 1 minus x, so it is in fact x minus 1 by x whole to the power 100. And since what we have done is coefficient of x to the power 99 in x plus 1 minus x whole to the power 100, so this is a simple concept. The answer is 0. Okay,